Hello everyone, how are you doing? Welcome to week 2 for Practical Math B, using slope to calculate opportunity costs. So here's our essential question for week 2. How can the slope of a production possibilities frontier be used to demonstrate opportunity cost? Our objectives for the week. We're going to be working on defining or relearning or reviewing slope and applying it to opportunity cost. We're going to compute the slope between 2 points. And then we're going to use this idea of slope to interpret what is the opportunity cost when we're working with economics. So take notes, use this video to help understand kind of what we're going for the week. Take a look at the reading, take a look at use this video to help you do the practice problems and to do the quiz. Let me know if you have any questions. All right, let's get going. What do you like to do after you're all done doing school for the day? For some of you, you may be just wanting to go be with your friends for a little bit. Some of you may just want to veg out, play some video games. Some of you go exercise. You may have sports after school. You may just read a good book. You may play music. There are lots and lots of things that we love to do in our free time. The amount of time that you have after school is what we call a constraint. For example, if you finish up, if you're all done with school at 4, and if you go to bed at 10, you have 6 hours. It'd be nice to have more than that, but we all have an idea of that time is not unlimited. We have a certain amount of time that we need to choose, and since it's constrained, it's limited, that's called a constraint. It's a resource that you have a limited amount of. When we choose to do any of the following activities after school, you have the cost of not being able to do any of the other activities. This is what we call in economics an opportunity cost. So, for example, after school, you're all done. You may feel like, I should get some exercise, but I'm just going to play some video games for a while. You play video games, all of a sudden it's dinner time, and you're like, whoops, you've had a lot of video game playing time, but now the exercise is not going to happen. So this is what you chose to use your time with. This was the cost. The cost was no exercise happened because we ended up choosing to play video games. Or you do vice versa. If you play sports, you may not have a much extra time to do all this fun stuff. You may be like, man, I do all my schoolwork, I do sports, and then the day's done. So there's costs as we choose where to use our resources. This is a big idea, and any business has to deal with these things. There's costs when we make one decision or choose to allocate all our resources one way or another. All right, let's take a look at a graph. Again, we're applying all this stuff to math here. On the graph, we got a line. We've got fish on the left side. We got chips on the bottom side. This is what we call a production possibility frontier graph. It's a graph showing the combination of two goods which can be produced given current resources and technology. Now, how to interpret this a little bit? What this is saying is I can either produce fish in my restaurant, maybe I'm a fish house, or I can produce chips in my restaurant, right? I have the resources to serve fish, I have the resources to create chips, and I have along this line here, I have the resources to make combinations of fish and chips. So what do you mean by that? Let's pick a blue here. So for example, I could make 30 fish and 0 chips, and that would be one way to use my resources. I'm choosing to make 30 fish, but the cost is there's 0 chips made. I could come down here and say, all right, what if I want to do 10 chips? Let's find that. That would be right about here. And that would be about 27 fish if I wanted to make 10 chips. Just kind of eyeballing it off the graph. So here I'm choosing to now take some of my resources invested into producing chips, but the cost is I can't make quite as much fish. I have a certain constraint, right? I have a certain amount of resources and I can choose what I want to devote it to, fish or producing chips. And then you go all the way down here, and if I really want to get to the other end point, I could make 0 fish plates, but 60 chips. So there's meaning behind all these points, and we can find any point on the line represents a combination, a possible combination of using our resources for chips and fish. There we go. That's a production possibility frontier. When we talk about this model, there are certain assumptions we make. We're kind of trying to use math as a model, and so we simplify it to only 2 goods. We're either doing just fish or chips, and I want to know what are the cost of choosing to do one or another. What are my options for one another? There's all sorts of other models that have that take into account lots of other variables, but for now we're just dealing with only 2 goods, one or the other. The amount of resources available, that means all your labor, all the workers you have, the amount of money you have to produce things, your natural resources, how much fish we have, how many chips we have, all of that remain constant. So we're having a constrained constant amount of resources that we can allocate to one good or the other. And then technology remains constant. We all know technology helps you produce things more efficiently or produce more of them. And so the idea is everything's constant. We're just choosing what do I want to produce more of, fish or chips in this case. What do the endpoints represent? Well, we already talked about that a little bit, right? The endpoints, the endpoints in this case just tell you the extremes, right? In this point right here, that's 30 fish and 0 chips. That's putting all of my resources into one good and none of it in the other. Or down here would be 0 fish, but 60 chips. So my endpoints represent my extremes. All my resources in fish or all my resources in chip. The line represents all the combinations of goods. So most business people don't want to produce just one or the other, but they try and find that sweet spot of what people want to buy. So maybe they may say, all right, well, the best thing to do is to produce right here. To produce 15 fish and 30 chips. Then we sell the most, we make the most money. That might be the most ideal situation. But the line represents all the combinations of the 2 goods. Points outside the line are impossible, right? If we have constraints on the amount of resources and we have constraints on our technology, then it's impossible to say, hey, let's do 30 fish and 30 chips, right? That point, I don't have enough resources to make that amount of money. So it's a limitation, it's a constraint. Points inside the line, so I'm going to put a little X there, let's say that's not possible. And so I'm not even thinking of it. From a business standpoint, I can't tell my customer, yeah, we can produce 30 fish and 30 chips. We'll do it next week. It's not possible. I don't have the resources to do that. Also, if I'm thinking about it as a business source, if I'm only producing down here inside the line, say 10 chips and 10 fish, that means I'm underusing my resources. I'm not using my technology. I'm not efficient. There's a lot of waste happening. And so if you can get a good model, if you can understand what's going on, you can help identify waste because you're trying not to waste your resources. You're trying not to waste your money. You want to maximize it as best as you can. So now this model is helping us find the ideal spot of what we can do and also helping us see, what is underutilizing our resources. So there we go, production possibility frontier. Fish and chips is a little bit silly, but it gives you kind of an idea of 2 goods and how we can think about what we want to do, make business decisions this way. Now, if we apply this to math and math classes that you've taken before, you've probably already encountered this idea of slope and slope related to graphs of lines. In math, the steepness of this line is called, we use the slope to describe that. But if we're dealing with economics, we can deal with all sorts of lines that help us understand business decisions, combinations of good, this whole production possibility frontier graph. So we need to develop our understanding of slope and even how it applies to economics and how it applies to producing fish and chips or whatever it is that I'm wanting to produce. So let's take a little bit of review with some slope here. So when we talk about slope of a line, slope is simply a rate showing the amount of change that happens between 2 points or with two variables, right? So as this changes, this other thing changes in response, and we get a graph, and we want to know how much change is happening. That's what my slope is. It's the amount of vertical change along that variable divided by amount of horizontal change with my other variable. Horizontal change being along your x values, your vertical change being along your y values up and down. Some of you may have also remembered it as rise over run. Some other things about slope: if a line is going from left to right and it looks like it's uphill like that, that's what we would call a positive slope because it's an increasing line. As x changes, y is increasing. We're stair-stepping up. If we have a line going downhill, for example, it's going down like that, that's what we would call a negative slope because it's decreasing. As x changes, we are subtracting y values and decreasing by amount over and over again right there. Let's do a couple examples here. Here's a line. This could be used to model some sort of economic situation. I got a couple points. I have the point 3, 4, and I have the point 9, 2, and I want to know what is the slope of that line. Well, sometimes if you have a graph, it's helpful to draw what we call a slope triangle, because now we can see how much is changing up or down in my y values, and now we can see how much is changing along my x values. So for my y values, we're starting at 4. There's a y value right there, and we're going down to 2. So from 4 to 2, that would be a decrease of 2. I'm going down 2 units. For my x values, I'm starting at an x value of 3. And from 3, I'm increasing all the way to 9 for my other x value. So between 3 to 9, that's a change of positive 6. So if it's my vertical change, which we decreased by 2, dividing by my horizontal change, which is an increase of 6, that would be a slope of negative 2 over 6, which reduces down to negative 1/3. That would be my slope. The slope of the line is equal to negative 1/3. And that just means when x increases by 3, my y values decreases by 1. And that's why we call it a rate. It's a comparison of what's changing between two things. Over 3, when that happens, we see a decrease of 1. Over 3 more, another decrease of 1. Over 3 more, another decrease of 1. It's the same constant change happening over and over and over again. Let's take another example. What if I don't have a graph? What if I just simply have 2 points? So what is the slope of a line with the points negative 15 and 8 and the points 22 and 130? Well, we have this idea of vertical and horizontal change, but we can think about it more with what's happening with my x and y values. Change is simply found by what's different. Let's subtract my two values. So here we got an x value of negative 15 and a y value in the first point of 8. In my second point, I have an x value of 22 and a y value of 130. So if I'm wanting to find my change, let's subtract the y values to find how much change happened there. So that would be 130 minus 8. And my y values look like they changed by 122. Well, now I need to contrast that vertical change with the horizontal change. It's a rate. I need to have two things going on. So let's compare my x values. So we did 130 first on top. So let's do 22 first on top. So 22 minus negative 15. You have to be careful with your negative numbers. 22 minus negative 15 actually turns into 22 plus 15, which is going to be 37. So there we go. 22, when we increase our x values by 37, we increase our y values by 122. I can go ahead and divide those. Let me get my calculator out here. 122 divided by 37. My slope is going to be about 3.3, which means as I go over 1 for x, it's a rate. It's going to increase by 3.3 along my y values. If I go over another one, it's going to increase by another 3.3. It's a constant increasing rate in this case. That's what my slope means. All right, so we've got slope. We reviewed slope. It's this idea of change and how I use to describe linear equations. But in this class, we're going beyond. We're trying to figure out how to use it in a way that makes sense for economics, that makes sense for money, that makes sense in kind of practical purposes. So let's go back to our fish and chips. What is the slope and what does it mean? Well, let's first figure out what do you have for the slope here. So the first thing, I'm going to make a couple points. I know I have this point and I have this point. And so the coordinates would be 0 chips, but I'm choosing to invest all my resources into making 30 fish. Or there's this point, 60 chips, all my resources invested are chips, and so I have 0 resources creating fish. There's 2 points. If I want to find the slope, I need to subtract my y values. So I'm going to have 30 minus 0. 30 minus 0, and I'm going to subtract my x values, 0 minus 60. And we end up with 30 over negative 60, which is the same as negative 1/2. So that's my slope. We got that from my 2 points. But what does it mean? All right, so our opportunity cost, kind of getting back to some economic principles. Remember, that was if I choose to one thing and I choose to invest my resources here, it's the cost of what I can't do with my resources because of certain constraints. When we look at this graph, as more chips are produced, as we go higher and higher amounts of chips, what happens to the amount of fish? The amount of fish decreases, right? So when I create chips, there's a cost of not as much fish produced. So as more chips are produced, a certain number of fish must be given up. Conversely, if I make more fish, some chips are given up. But we already found the slope was negative 1/2, but what does that mean? It means as I increase the amount of chips by 2, remember this 2 is my x values, so as I'm changing 2 units along my x values, what happens as I increase my x values, my chips, which is x, along by 2, I see a decrease of 1. I decrease the amount of fish produced by 1. So this slope is helping me understand my opportunity cost, a slope of negative 1/2. That means I know, okay, if I want to make more chips, there's a cost, and I know exactly what that cost is. If I make 2 more chips, that means I have to decrease the amount of fish by 1. If I make 10 more chips, well, if my amount of chips I increases by 10, then I have to decrease the amount of fish by 5, because negative 5/10 is the same as negative 1/2. So the slope helps me see what my opportunity cost is. It helps me know if I choose to do this, this is what I'm going to have to give up over here. Sometimes we have a model that's not a straight line. So let's take a look at what we got going on here. We got a nice little graph again. Let's look at what my labels are. So my x values look like they're the amount of televisions produced. So if I go from 0 TVs, we can go up to 4 TVs produced, to 7 TVs, 10 TVs, 11 TVs. The x-axis is telling me how many TVs am I producing. Remember, these production frontier graphs are comparing two goods. So my other good looks to be radios produced. So this is an electronics company choosing to invest in radios and televisions. And I can go from 5, 9, 12, 15 radios. Finding the endpoints, it looks like I could use all my resources to produce 15 radios. 15 radios and 0 TVs. That's that endpoint. Or I could produce 0 radios and 11 TVs. But what's different here is this is not a straight line. So we've got kind of a curved thing going on, which makes it even more interesting when you're trying to choose the best combination of goods to produce. So let's think about it in terms of slope, though, and opportunity costs. So I can make 15 radios and 0 TVs, but check out this point right here in B. So B would say, well, I could also choose to make 12 radios, so 12R, and 4 TVs. So between those 2 points then, what happened? It looks like we increased our amount of TVs by 4, but we had to give up 3 radios. So we decreased our radios by 3 when we increased our TVs by 4. So the slope between A and B then is -3/4. There's our opportunity cost. I made 4 more TVs, but I had to decrease the amount of radios by 3. But maybe that's not so bad, right? TVs, we get more money if we make a TV, and so it's better to make more of something. I'm making 4 things and selling them, whereas before, I only gave up making 3 things. So I'm producing actually more now that I can then sell. So this part B might be better for that reason, and seeing this opportunity cost as the slope helps us realize, oh yeah, let's shift from making only TVs, now making only radios, let's make radios and TVs. This can be better for our company. But this is a curved graph, so we can compare it to point C. Let's see what's going on in point C. So here, in point C, here we're making 9 radios, but I'm also making 7 TVs. So what's going on with the slope there? So from radios, along my Y values, we decreased by 3 more radios. And so I made 3 less radios, but I did make from 4 to 7, I did make 3 more TVs. So my slope, -3/3, is just going to reduce down to -1. So in this case, we can see, okay, the slope, it's decreasing, it's going down a little bit more. And instead of getting 4 TVs for cutting 3 radios, now I'm still cutting 3 radios, but I'm only getting 3 TVs. So I'm starting to kind of find what my resources and technology can handle. It still might be better. I still might say I like C better because, I can make more money off of TVs and radios. And so producing 3 more TVs is worth giving up 3 radios. So we can factor that in and whatnot. But the idea is our slope between these 2 points, B and C, is different than from between A and B. And so we need to consider that if we're trying to be smart with our production, with our business. And if you go on, you notice that all of the points, if I keep going on, from C to D decreases even faster, and from D to E decreases even more. From C to D, the slope, it increases by 3 along my X values, but from 9 to 5, it decreases by 4. So that's the slope between C and D. And then from D and E, it's even worse. We made from 10 to 11, so I made 1 more TV along my X values, but to do that, I went from 5 radios to 0 radios, so we decreased by 5. This last slope, decreasing 5 radios just to produce 1 more TV, I don't know if that's worth it. That seems like a big cost for me. So this from D to E, I may say, that's not worth trying to eke out one more TV. Let's back it up a little bit. And the sweet spot I would think would be either B, C, or D, depending on how much we actually make. But there you go. We had to actually calculate for a curved graph in this problem, 1, 2, 3, 4 different slopes to understand what's going on and how a different slope means a different cost for trying to produce that amount of goods. So to wrap it all up, as we make more televisions, the tools we are using to make radios are not quite as efficient as they were, which increases our opportunity cost. Essentially, we have to give up more radios to gain fewer televisions if we go farther and farther down this graph. So businesses, they have all sorts of choices they need to make about how they use their resources to produce and sell goods and to find the right amount, to maximize their production, to use their goods in the right way, to make the most amount of money they can off what they produce, and also to not have inefficient waste, to not underutilize the resources. So being able to gather data, kind of like what we did, being able to quantify all of our constraints as a business on a graph can really help businesses see the opportunity costs and make the best business decisions for the company. So there we go. That's what we talked about. We took our idea of slope and applied it to this idea of opportunity costs. And so you hopefully have an idea of how slope in math can actually be used for businesses to understand what's going on better. We reviewed how to calculate the slope between 2 points, and we used the slope and could interpret it as an opportunity cost for making one good versus another good. All right, good class today, good work. Let me know if you have any questions as you're working on the assignments for week 2.